lab report on projectile motion. The purpose of this lab is to observe and analyze the motion of an object that is thrown and moves like a projectile. In this lab, we will use a video of a paper ball, which is our system, being thrown in the air, which is our surrounding, to show Newton's second law of motion, which states that the acceleration of an object is directly proportional to the net force acting on it. In this lab, we observed that the predicted model does not quite match the experimental model due to possible movement of the paper ball in the z direction as well as human error. The main physics principles covered in this lab are Newton's second law of motion, seen here, where the final velocity is equal to the initial velocity plus the net force over the mass times delta t. Within the net force is included the force of drag. This means that in this lab we are modeling that F net is just the force of gravity and F net is the force of gravity plus the force of drag. The reason we are using Newton's second law of motion is to measure and observe the relationship between position and time and how our perceived net force affects the paper ball. Our system is the paper ball and our surroundings is the air. Our experiment, we used a ball that had a mass of 0.00096 kilograms, and we used a meter stick for calibration. However, in this video, due to orientation, it appears sideways, but we did throw the ball vertically. Code I used for this lab. This is to set the initial values of the system and the surroundings, as well as the calculation portion within the while loop. Here, our time was 0.47 seconds, which is roughly the time that we measured within the tracker app. This is the data we received. As you can see here, this is computer model data, as well as a visual of the computer model. Here we see a big discrepancy between the gravity and gravity plus drag and our actual model. Again, this has a lot to do with human error and possible movement throughout the experiment. That might come up is, would the terminal velocity of the ball change depending on the orientation it is moving in? The answer to that is no, as all objects have a terminal velocity that is dependent upon their mass, gravity, and air density. So as long as these stay the same, so will its terminal velocity. Thank you.